about it.
Okay, any questions? Yep.
Okay, is there any risk that the seeds will be sterilised due to the radiation dose they'll get on transit, or are there precautions in place?
The fairing itself should be able to protect it from most cosmic rays and radiation itself.
So the radiation from the nuclear reactor.
Oh, nuclear reactor, however, we haven't really considered it yet. I suppose we could put some kind of
small nuclear reactors, fission reactors, have been made in the past, and they have been reasonably safe.
So it's more the background nuclear dosage. So if you talk about sending humans to space, you talk about having a large shield to stop people getting cancer essentially. But if you're sending robots, you don't, as long as they're rad hardened, you don't really care. Don't worry about that. But if you're sending organics, you sterilise your seeds in a way that it will get there in 2 years, and they won't even grow because they'll be inert. So
I expect we'd actually have to try that out, because I mean, in Chernobyl, for instance, plant life still is there, even though it's all irradiated. So I guess we'd actually need to try an experiment, you know, to see,
so
or at least have a look at the literature and see what happens.
Because obviously seeds can, quite hard and can exist in extreme things, but it was just one case where you'd actually thought about that bit. The safe, you may grow them, but they're irradiated soya. People may get rid of it for 6 months before.
Well, so we kind of expect that if there's any sort of large-scale human population going to Mars, that they would probably use a nuclear reactor for their all general purposes anyway.
Yeah, but it's not the radiation is not coming from the RTG. It's coming from its background. So it's the dosage it accumulates on its 6 month transit.
Yeah. Well, so we could we could do the calculations, and then I don't know, you might set up like an experiment, I guess. Ask if we can put seeds near nuclear reactors for them.
Yeah,
a year or two.
We have to really test. We can't just say yes, it'll work or it won't.
The ISS has had plant growth payloads before.
Yeah.
So something we can look at is how much the radiation they've had accumulated over the time period of the experiments, to see whether that actually had any effect. They did do an aeroponics experiment on the ISS, and that looked very promising.
Yeah.
Obviously, it's zero gravity as well. But
what other diversity then do you think you can add to your aeroponics other than soy?
Well, we were going with soy initially because it's a very, I think 60% of the world consumes soya, so it's very.
If you're saying we then have the option to spend, say, another.
Yeah, hopefully the greenhouse would be designed so that it wouldn't just work on the soya. You could change soya for potatoes or something like that.
Have you thought about what other things would be successful in your greenhouse essentially?
Well, aeroponically,
pretty much
potatoes have been used. There's plenty of variety. I guess, it comes down to what do the seeds look like? Are they, because potatoes, normally you plant a potato to grow a potato, don't you?
Yeah. So
that might not be as volume and mass efficient as, for instance, the soya, or some places suggested wheat, things like that, because they are sort of bases of our diet now.
Because initially you set up experiments to test out each different type of crop, and then if it all works, then you can imagine having multiple greenhouses on Mars, making multiple different types of crops for the human settlements there. So it would be a testing kind of thing to see which ones would be good to use and stuff like that.
Was the surface clear or black?
Sorry?
Was your outer surface clear or black?
We were debating whether to be transparent or opaque, and we even thought about materials which could change their opacity.
There is several ways that you can change the opacity of the material. If we were to solely use halogen lamps to grow the crops, then we would have to think about some sort of layer to decrease the amount of energy going out of the greenhouses. If we were using some sort of hybrid of halogen lamps and sunlight, obviously we'd have to find some middle ground. But as of this stage, it was transparent for the majority of the project.
Yeah.
But I guess that's something we've got to look into and decide.
What's your temperature rating for a Martian payload?
It depends where you are, but it can vary between 17 and minus 100 and 100 something degrees Celsius. The average is about 55 degrees. So it is quite substantial. Temperature control, we were mainly going to get around it because the lamps produce a lot of heat, and air circulation should be able to distribute it throughout the whole of the greenhouses. And then, of course, if it gets too hot, we're a bit screwed.
Land-based. Does your solution have to be land-based?
Sorry, I didn't.
Does it have to be land-based?
Land-based.
Logistics would be a lot easier on land because otherwise you'd have to keep shipping in crops from orbit.
Well, no, I was thinking more an orbital one.
Yes.
Yeah, you'd have to keep, because if you've got if your house is on the ground, you'd have to, it would become more convenient to have your food where you live as opposed to having to drop it in from orbit every time for your shipment.
I guess that would depend on the method by which we start colonising Mars. If we were to have a space station first and then land on Mars, that might be an interesting option. But if we're solely on the surface,
A Martian surface roving greenhouse.